Hello and good day everyone. This is Kabir. This is our second day or day 2 of basic time series analysis, specifically macroeconomic analysis or modeling class. Today we will discuss about time series data sourcing, specifically from World Bank, performing a stationarity test, and at the same time running a regression based on the outcome of our stationarity test. The first thing I'm going to do is to head to my browser, which is Chrome. I'll head to Chrome. You can use the type of browser you want, but for this I prefer Chrome. I'm going to use Chrome. As you can see, I'm in Chrome. Searching information from Google involves 3 things you need to know, which will help you a lot, specifically in trying to source time series data. Sourcing time series data is not as easy as it sounds, because sometimes you might keep searching. If your keywords does not tally with the information in Google, you can't get your result. The 3 things involved in searching involves crawling, indexing, and ranking. I'm going to explain each. Crawling. When you type a search in the Google search engine, your search will go through all the information on Google. It will scroll into all information on Google, and it will arrange them in one place, which is called indexing. It will put them, it's like creating a database for the related information that you're searching in one place. The next thing is ranking. Ranking here simply means it will rank your search, that is, it will rank the information that it will give you based on your keywords. So understanding your keywords is very important. So the first variable I'm going to source from WDI, because I said we're going to use World Development Indicators. If you like, you can go to macro trends. If you like, you can go to other sources to get the data, but for this I'm going for the World Development Indicators. So I'll go for Nigeria GDP WDI, then I'll click on enter. WDI. Now click on enter. Okay, let me open it complete so that you can see what I'm doing. So here, as you can see here, this one tallies with this one, is at the top. This one is ranked the top as it relates to the keywords I'm searching. This search follows, this one follows, up to the last thing in that result. So the next thing is I'll click on this link. I'm going for this and see if we can be able to get our variables from here. It's opening. I don't know why it's loading like this, but I think okay, it has opened up. So here here it is. We're searching for Nigeria, and actually we have enough data for Nigeria right from 1960 up to 2024, but not these values are in US dollars. So the next thing is we go to download. We can download it as CSV, we can download it as XML, we can download it as Excel. If you download it as CSV, it will come in a zipped file, which involves a tedious process for you to identify what you're really trying to use, as it comes with 3 different Excel files. XML is entirely out of scope for someone who is in economics, and the next thing is in Excel. So I'll download it in Excel. I'll click on download and I'll get it. Okay, I've already downloaded it. I think I'm just going straight to use it. Right, okay, it's going to download again, and you see I already have them all. But once you download them, the next thing is to head to where you downloaded it. For me, I am saving them for me directly by virtual. They are in downloads. As you can see, they are all in downloads. Here it is. So I've moved them to time series for easy identification and cleaning. So the next thing is to open the time series folder, which is this. I have opened it. Then create a new Excel file for the cleaned data. So I'll double click on it and it will open. It's opening. Okay, as you can see, my file has opened. So the next thing you're going to do is, it depends on the type of format you want, but for me this is what I prefer, except if I'm modeling a panel data. So the first one will be dates. You're going to give your datasets acronym names, sorry. So the next one is GDP. The next one is inflation, so I'll name it inflation, and the next one is unemployment, UEM. So for the dates, I'm starting from 1980. After writing it, I'll come here, as you can see where it is. So your cursor directly will become small like this, then you drag it down up to where you want it to be. I think so. We'll leave it around here. All this will come down, so you click here and you click on fill series. I've clicked on it and it worked. So come down and see what we've got. You see, it's more than 40 years, which means the data is asymptotic. So let's have something like this, 2023 up to 2023. So let's say we make it 47 years, 24, that is 29, that is around 46 years. So the next thing is to get the data. The next thing is to get the data. So to get the data, sorry, someone called me via WhatsApp. We have the GDP. The next thing is to head to the GDP, to the Excel I just downloaded from the WDI. So I'll click on it, and as you can see, here is the GDP. Here, API NY Nigeria GDP. So I will click on it. I will open it. After opening it, we have different sheets here, metadata indicators, here metadata countries, and here is the data. So I'll click on Control F and I'll write Nigeria. You see, Nigeria is selected. So I'm going to close this box, highlight this cell, color it for easy identification. After this, I'll go up. I said we're going to use the data from 1980 up to date, so I'll click on this cell, I'll color it, then come down. Okay, as you can see, this is the main reason for the coloring, so I'll highlight it, the particular cell I'm using. As you can see, I'll then copy it. After copying, I'll come to my clean data. Inside this cell B2, I'll click on, if I paste it like this, it will go the way it is, but I don't want it to be like that, so I'm transposing it here As you can see, this is transpose, so I've transposed it. And let's see if we have something we really want. Yes, perfect. That's what we want. The next thing is to go for inflation. Then I'm closing this file directly. You don't save because I'm not using it. I don't want the colors to be saved in the data. So here you identify inflation. This is inflation. You see API fp.cpi. So you double click on it, you open the file, and you wait for it to open. And as you can see, the same thing we use the same format we did before. You come to data. This is the data that contain all the world countries information. So you click on Control F, you click on Nigeria. Here is Nigeria. Close the search box, color it, then scroll here a little bit, go up. We are starting 1980. Oops, sorry. 1980. You color in this color, this cell, and you go down. After coming down, you can identify it here. You see, so I'm highlighting this. You can use Control and the left arrow key, the right arrow key, sorry, to select all, or you can use your mouse if you want. Okay, and Control C to copy it. Then I'll move to my cleaned data and I'll do the same thing, transpose it. The next thing is unemployment, which I'm going to close this. Don't save because I don't want the colors to be there. And you minimize this and you come to unemployment. Okay, at the same time, the same thing you did before, you come to data, then you click on Control F, you click on Nigeria, then you click on this, color it, and go up. This is the data I think it's full of missing values and all that. You see, it's full of missing values, but anyway, we're going to use it. Maybe later on in consecutive courses, I'm going to explain how you can sort all these things. Sorry, let me see. Okay, here. So you come down, you see it's full of missing values. So I don't know what year the data starts. AG. Let me color the AG so that I will not make mistake in taking it to my okay, it starts in 1991. Wow. Okay, here it is. So I'm highlighting it. Control C and bring it here. You see it starts here, 1991. So I'm transposing it. As you can see, all these are missing values. We'll just run it like that. Maybe in the course I'll explain how you can solve the issue of missing values or tackle the issue of missing values. So what I'm going to do next is to remove this coloring. I'll highlight the B. You click on this B, come here and click on here, this one. It will automatically take out the colors. The same applies to this. You click on this, it will go, and at the same time you click on this, it will also go. Oops, I thought. Okay, perfect. So you have something like this. What am I going to do next? The next thing is to import it into eViews. Import the data into eViews, which is what I'm going to do right now. So here is the cleaned data. So what I'm going to do is to open my eViews. I've opened my eViews. Right. Okay, we have something like this. So what I'm going to do is to close this window. So the simplest and easiest way, oops, I opened two eViews file. Okay, the simplest and easiest way, I'll just highlight the data, except if you're modeling panel data. If it's normal time series data, or if it's normal time series data and it's already dated in a way that you want, you are not going to change the range or time format, be it monthly, you want to make it annually, or annually you want to make it monthly or weekly or quarterly. If it's already in a format that you want, you can just drag it and drop it here. Right, this is an issue. I'm going to do it again. As you can see, sharing violation for file C users and all that. I know why that is popping up, and I'm doing these things so that you understand this error to avoid doing that. So I already have the data here, so you click on save, you save it. The main reason why that error is popping up is because this file is opened in Excel. So I'm going to close it. I've closed it already. I'll just put it here, and as you can see, it has opened. So you keep on clicking on next, then finish. No. Link imported object and alpha objects to external source. No. So the next thing is to perform a stationarity test. Stationarity tells you whether the time time series, the mean variance of the time series, is the same or is time variant. Let's see. Okay, here is Wikipedia. We already have something here, and as you can see, stationary process. Here in mathematics and statistics, a stationary process, also called a strictly stationary process, or strongly stationary process, is a stochastic process whose statistical properties such as mean and variance do not change over time. More formally, the joint probability distribution of the process remains the same. It is a different observation. Let's say 2010 and 2011 or 2012. You see, the time varies. This one you collected in 2012, and this one you collected in 2011 or 2012. So this implies that for the data to be stationary, the mean for the 2 years must be time variant. They should not change. The variance also should not change. This is what we're trying to look at. This explains whether among the data sets there is a long run relationship or there is a short run relationship. We're going to run that in eViews using these data sets that we sourced to see whether they are related in the long run or short run. So we're starting with GDP. Let me redo that again. You come to GDP using your mouse, you double click on it and it will open. Then you click on view. The next thing is unit root test. Then you come to standard unit root test and you click on it. Then there are different types of unit root test: augmented decay Fuller, GLS, Philip Perron, depending on what you want to use, on which one you want to use. All these are in automatic except for this that I will be changing. So I'm going to test at level, which is I0. As you can see, the data is not stationary at level. The data is not stationary at what level? Because the p-value is greater than 0.05. So I'm rerunning it again, unit root test, and I'm putting it in first difference. Oh, not first difference, I'm start trend and intercepts, the same thing here. So I think we'll just go for first difference and forget about this. So first difference, as you can see, the data is now stationary after first differencing, which means our data is stationary at I1. That is after first differencing. The variable fails to exhibit stationarity at level, but after first differencing. So The next thing is we go for inflation. Unit root test, standard unit root test. We go for level first. We click on OK. Well, you see, inflation is stationary at level directly. It's stationary at level. That means the mean and variance are time variant. They do not change much over time between the years. So then the next thing is unemployment. Let's see what we've got. Unit root test, standard unit root test, level, and we'll run it. As you can see, it's also stationary at level. Here is what here's what I'm using. Here is what I'm checking. Here, this is the box I'm checking. This is what I'm more concerned with. I'll explain this and this later on in the course, but for now, here is what I'm more concerned of. Alright, so the three variables exhibit, stationarity. GDP failed to exhibit stationarity at level, but after first differencing. So the next thing is to run directly. We have a kind of mixed order of integration among the variables. So if we regress them like this, we are going to get what is called a nonsense or spurious regression. What are we going to do next? The next thing we are going to do is I think we'll just handle linear regression. We'll explain more within the course. So let's say GDP. Here we have a GDP. Let's say you want to model them. You click on GDP and you hold the control key. And you click on GDP. Then you come to inflation, which is inf. You click on it and UEM, and then you click on it. After that, you right soft key on your mouse, you click on open, and you open it as equation. There are different models, but the first one is the multiple linear regression. After you click on it, you just click OK. As you can see, the R square is very, very low. The R square is what? Very low. As you can see, the R square, sorry, this is not what I'm supposed to use. The R square is very low, as you can see. So and we have a kind of significant p-values, but the R square is low. This explains that only 26% of the variation in GDP is explained by inflation and unemployment. That means something is wrong with our data. So let me close this. I think so. Here, let me interpret it. We'll correct it in the next class. So here we're trying to predict GDP, future GDP, based on these two. Despite having a very low relationship between the variables, we'll explain them. Maybe we'll explain why this R square is low in our next class. GDP, which is the gross domestic product, inflation and unemployment. So let's say GDP, inflation, this minus 4.01 implies that a unit increase in inflation will lead to a unit, let me put it again, a unit increase or a percentage increase in inflation will lead to a 4.01 decrease in GDP. That means if inflation increases, GDP will go down by this percentage. Also with a statistically significant p-value of 0.01 supporting this statement. On the other hand, a unit increase in unemployment will lead to an increase of 8.86 increase in GDP. That is, if unemployment increases, GDP will also increase. Also with a statistically significant p-value of 0.046. So I think we tried to explain this. The W-Watson statistics here should be 2, but you know, this means there's a serious issue with our data, and this is just something that is basic and we can't explain everything here, but maybe within the course I will explain all these things and the remedies to tackle all these problems in the consecutive classes. Thank you so much. See you in the next slide.